So we know that graded potentials can either be excitatory or inhibitory, or a depolarization or a hyperpolarization. So on this first graph, this shows a depolarization. You can see it starts at 70 and it comes up towards threshold and then back down. That is a depolarization. So it's excitatory. It's getting the membrane more positive. So we call that an IPSP. And that is called, or excuse me, an EPSP. Sorry, I'm getting ahead of myself at the moment. So this is an EPSP. So an excitatory post-synaptic potential. Meaning we've gotten a depolarization or an excitatory potential on the postsynaptic membrane. So over here. On the bottom here, we have an IPSP. So that is inhibitory. And look at here, this is a hyperpolarization. Change my color. So hyperpolarization. The membrane is getting more negative. It's going away from threshold. Again, we call this an IPSP, or inhibitory post-synaptic potential. All right, so this is a potential that will happen here that will move the membrane away from threshold. So your excitatory postsynaptic potential will want to get the axon hillock toward triggering, toward threshold, and an inhibitory postsynaptic potential will want to get it further away from threshold so that it doesn't fire. Okay? What causes this? Well, the depolarization is easy. Depolarization is where sodium and potassium are moving through those chemical gates, through those chemical channels. And the movement of those two ions causes the membrane to get more positive. In an inhibitory one, it's chlorine. So chloride ions and potassium, I think. Hold on. Yes, potassium, sorry. So potassium and chloride. So that means chloride is coming in and it's a negative ion. And then, of course, potassium's leaving, it's a positive ion. And both of those things cause the membrane to get more negative. Okay, so this is movement of those two. So now we have depolarization and a hyperpolarization. So a graded potential, one graded potential generally won't cause much, won't get down here to the axon hillock to either inhibit it or to stimulate it. So we pretty much need more than one, okay? So we can add those up, all right, which is called summation. We kind of looked at summation with the muscle, and this is similar to that. So we have something called, let's see, hold on a second, make sure I've got the right terms here. Okay, so temporal summation is where we have graded potentials coming from the same axon terminal. Okay, so more than one stimulus from the same axon terminal. So for this one here, so let's say I'm sending in one action potential and two action potentials and three action potentials over this same one. So that's going to stimulate more neurotransmitter, and that's going to get a higher or a stronger graded potential. Okay, so that is called temporal summation. All right, spatial summation is where we add up the action potentials from different terminals. So let's say I got an action potential from here and an action potential from here, and let's say there's another one here and an action potential from there. That is spatial summation. Okay, so temporal is just firing the same one over and over. Spatial is adding up the firing of different synapses. Okay, so we know we have excitatory ones and inhibitory ones, and we can sum those together. Let's say these are all excitatory. That's going to make a higher or stronger graded potential, and it's going to be more apt to get here to trigger an action potential along this neuron. But let's say I sum up some excitatories and some inhibitories together, that could actually cancel each other out. So we can add excitatories to each other. Do that differently. So excitatory plus excitatory plus excitatory. We can add inhibitory plus inhibitory plus inhibitories, or we can add excitatories and inhibitories together. Okay, and whatever comes up the most is either going to trigger an action potential or not trigger an action potential. So that is how EPSPs and IPSPs work. Okay, so you want to go over that because that can get a little bit confusing.